Hey guys. Hey Sophia.
Hey.
Hey. What's going on?
What? Am I muted?
I can hear ya. Now I can't hear ya. But I'm glad you're here. All right, we'll give everybody 2 more minutes and we'll get started. I think everybody should be up on the techie stuff now. Jake, Kirsten, Mackenzie, Sophia.
Yeah, Lydia's asking about it.
Okay. Is there any way somebody could send her the link? Because I did send it to her, but...
Yeah, I could try.
Okay. And I can give you the link, like, here. See if that'll work. Oh, Lydia's here.
Oh, she made it.
Lydia, yay! I'm so glad you're here. Okay, we'll give everybody 1 more minute and we'll get started. If anybody has any questions, let me know. My computer is like crazy.
I wasn't up for 7.3.
You were doing what?
I wasn't up for 7.3 because I was sick that day.
Okay.
Yeah.
Then maybe do some of those at the end.
Yeah.
Okay. All right, so let's go ahead and get started. I'll go ahead and record this, so if somebody jumps on later, they can. All right, so we are in the last part of chapter 7, which is awesome. We've been talking about the sine, cosine, and tangent ratios, which are pretty cool. I mean, they're one of those things that you actually will use and probably will come across in several other places. Person, they're on the ACT, right? So let's go ahead, and I think at the end of class we were talking about the sine and the cosine ratio. So let's do a quick review and then do a couple sine and cosine problems, and then we'll talk about our last section here. Okay, so if you remember, the sine, cosine, and tangent of an angle are actually ratios of the sides of a right triangle. So we have this cool little right triangle tool, right? And if we have an angle here that we'll call theta, that's a messy theta, and we have sides A, B, and C. Actually, let's not call them A, B, and C. Let's call them, this is right, let's call this the opposite side. Okay. We will call this the hypotenuse because it is the hypotenuse. Hypotenuse just means the longest side of the right triangle, which is across from the 90-degree angle. And then this little guy here, if I can sneak it in, is the adjacent side. ADJ. Okay. We know it's adjacent to theta because it's not the hypotenuse. So there's two sides that are adjacent that touch theta, right? One is the hypotenuse here. One is the adjacent side. The adjacent side is the one that's not across from the 90-degree angle. Okay. So just to kind of review, if we wanted to find the sine of theta, the cosine of theta, and the tangent of theta, we're going to go to our friend SOHCAHTOA. So SOHCAHTOA tells us that the sine of theta equals the opposite over the hypotenuse. Okay. The cosine of theta is the ca part. That's the little that's the one I have a hard time spelling, right? Ca is the adjacent over the hypotenuse. And then we have TOA, which is TOA, right? The opposite over the adjacent. So this encompasses 7.5 and 7.6, but this is really important because we can use this to solve a lot of triangles and solve a lot of problems that are real world problems because that these ratios are always the same. So if your ratio of your opposite side to your adjacent side is 0.5, then we know that the angle is always 30 degrees, let's say. Now that's not exactly true because I just made that up, but these are actually really powerful ratios because they are always true. Your calculator has them, all that good stuff. So let me take a couple examples from that we didn't get to in class. And let's do a couple of these, okay? So, roller coaster. You're at the top of a roller coaster. You're at Kings Island. This is the Diamondback. Okay. The roller coaster is 100 feet above the ground. I think Diamondback is technically taller than that. Who knows how tall it is? So this roller coaster at the top of the hill is 100 feet. And you can see it labeled on the other side, but I like it over here. 100 feet. Now, if I measure from the bottom of the ground, this is going to come in at a right angle, even though I didn't draw my line at a right angle, right? The angle of depression is 44 degrees. So that's kind of a new word, or new concept, the angle of depression. So the angle of depression is simply from horizontal, okay, how much of an angle do I go down? And you can see it's nice and labeled on here, so it's not too hard to see. So the angle of depression is 44 degrees, right? If I know that this makes a right angle, let me rephrase this the other way. Do we know what this angle is or this angle is because we know the angle of depression is 44 degrees? We do, right? We know that this one down here is actually also 44 degrees because this is two parallel lines that are cut by a transversal. So these are alternate interior angles. So this is 44 degrees down here, right? And if this is 90 and this is 44 degrees, then this angle up here is going to be 46 degrees. Okay, does everybody understand how I came up with the angles here? You could also know that this makes a 90-degree angle. So 46 plus 44 is 90 degrees. So that would be another one.
Times 44 is 90 degrees.
I hear you, Miss Sophia.
Oh,
got it.
Oh.
Okay. So everybody got the angles. You good? Give me a thumbs up in the chat if you got it. Oh, that's totally, when I clicked on the chat, it went over there. was trying to give everybody a smiley face in the chat, but kind of kicked me out. All right. Well, I guess some of you can't do thumbs up. I forgot. Oh, there you go. Jake gave me a smiley face. He's my new favorite math student now. I forgot that some of you, if you're on your phones, you can't chat in the chat. So, all right. So we have a triangle. Now that we have a triangle, we can kind of ignore the fact, thumbs up. All right. Awesome. Now we can kind of ignore the fact that this is a roller coaster, and now we just have a math problem. Maybe we would like the fact that it was a roller coaster, right? All right, so we know that this is 100 feet, right? This is 46 degrees. This is a right angle. This is 44 degrees. And this is X. Oh, we need to figure out what they're asking for. How far do you ride down the hill? Well, this would be a crazy roller coaster if you just went straight down the hill like this, but I guess they have you bottoming out after it. So how far down the hill do you go? Well, there's multiple ways that you could go about this because you have multiple angles here, right? The one thing to note, though, is that what you're trying to find, your X, is the hypotenuse, right? It's the side across from the 90-degree angle. It's the hypotenuse. So I know that I'm probably going to use either sine or cosine. Sine and cosine both have a hypotenuse in it. Tangent is good. It tells me opposite over adjacent, but I'm not trying to solve adjacent. I'm trying to solve the hypotenuse, right? So let's pick one of these. Let's pick 46 degrees, okay? And I know that I have 100 degrees, which is adjacent, and I have X, which I'm trying to solve, which is, excuse me, hypotenuse. So I'm going to say that the cosine of 46 degrees, right, is equal to the adjacent over the hypotenuse. HYP. Okay, the adjacent side is 100, and the hypotenuse is X. So if I do a little bit of math now, I have an X down here and a cosine of 46 over here. So I can cross multiply. So I get X times the cosine 46 degrees equals 100. And then I divide both sides by the cosine of 46 degrees. Cosine of 46. So I get, so this is where you're going to bust out your calculator. Let's see. Let's see how good my computer calculator is. Nope, computer calculator is not going to cut it. I'm going to have to bring up Desmos to do it. Okay. So if you have Desmos, you can definitely do this. It's 100 if I can type correctly, 100 divided by the cosine of 46 degrees. Now, I just came up with that my length of my roller coaster is negative 231 feet. That does not seem right. What went wrong? Well, it's because you have to be careful. You have to be careful what your calculator is set on. So this goes if you have a TI calculator, if you're using your phone, if you are using Desmos, you need to make sure that you're set on degrees. So you probably haven't learned this yet, but there's actually two measurements for angles. Degrees is the one that we mostly talk about in real life, right? But there's also a measure called radians. And so that's more kind of a scientific, mathematical term. So we want to make sure that we're on degrees. So you'll see when I do that, I get a much better answer, that my hill is 144 feet, basically. Okay. If you have your calculator that you're going to use, I want you to try this on your calculator and make sure you know how to type it in correctly, and then you end up with 144 feet. Because a lot of times that's the hardest part, right? Is to figure out how do I get the 144 feet? How do I find the cosine of 46 degrees? If you really wanted to go old school, and I haven't done this yet, you could search for a sine, cosine, tangent chart. So back in the olden days, before calculators, people would use a big old chart like this. Maybe if it's going to open for me. Oh, well, this just shows the easy ones. So you can have this big old chart that says, oh, if you take the sine of this, then it's this. Like it's a huge chart. That's how people used to find it. But now we have calculators, so we're not going to spend too much time on that. Okay, back to this problem. What if you, instead of using 46 degrees, you said, no, I want to use 44 degrees because I like that better. Okay, then I just need to think about my problem, because if I'm using 44 degrees, okay, then I'm talking 100 is my opposite side and x is my hypotenuse. So if I use 44 degrees, I need to say the sine of 44 degrees equals the opposite over the hypotenuse. The opposite side is 100 and the hypotenuse is x. You're going to end up, when you do your math, you're going to end up with 100 divided by the sine of 44 degrees. Okay, now if I switch to my calculator, 100 divided by the sine of 44 degrees. And I end up with the same thing, 144 feet, right? So one thing cool about these problems is that there's more than one way to do it. So just because you decided to use the cosine and I decided to use the sine, I'm going to still end up with the same values. It just, as long as you apply the ratios correctly. These look similar to each other, but this is the sine of 44 degrees and this is the cosine of 46 degrees. So they're actually, those two values are actually the same. But if, but I just have to make sure that I apply the cosine or sine ratio correctly to end up with the right thing. Okay. So let's try one more, and I really want you guys to, we're going to try about this railroad crossing here. And I want you to try them as we're doing them. So really try it and put it in your calculator. Don't just trust what I'm saying. Put it in your calculator and make sure that your calculator is giving you the right value. Because it never fails when I give someone the test, then I end up with someone's like, what? Everything's wrong. And it's something with their calculator more than them not knowing how to do it.
How do you put it in degrees?
Why do you put it in degrees?
Well, how?
Oh, your calculator?
Yeah.
So Desmos, it's the little wrench, right?
Yeah.
And you just click on degrees. If you are using your iPhone calculator,
I'm using the Real Deal.
You're using the Real Deal?
Yeah.
Then it should that's good. So it's going to be under mode. No. Hold on.
Like I see the DL mode degrees. I don't know. I don't see it.
It is, hold on. I don't need a YouTube video. I need a. Yeah, it's going to be under mode on your TI calculator. So if you go under mode, there should be a toggle, and one should say radian and one should say degrees.
Let me see. Oh, I see it. Yeah.
Yeah. So just make sure it's on degrees.
Okay.
Another way that you can really check really easily is you could pick, if you take, let's see. The sine of, I'm trying to think of a number that you could. I don't know. I don't have a good quick check. Let me think about that. There should be something that you could put in to see.
Yeah, I got it.
Yay. Awesome. All right. So you guys, I want you to try it. I'm going to do this problem, but I want you to try it too. Okay. So a railroad crossing arm that is 20 feet long is stuck with an angle of elevation of 35 degrees. So I think angle of elevation makes sense, right? It's elevated by 35 degrees here. Find the lengths of X and Y. So this is a, I'm going to draw my triangle a little bigger here. Maybe. You got to flip it. There we go. So we got our thing. And so I want you guys to start working. So I'm going to give you a minute or two to start trying to figure this out. And then I will check, or I'll start doing it too. So see if you can first figure out X, and then go on to figure out Y. Okay, so I'm going to start solving it. If you're still working on it, keep working. But hopefully we end up in the same spot, right? Okay, so first I'm going to solve for X. Okay, and I noticed that X is the side that is opposite of 35 degrees. And what they've given me in the problem is 20 feet, which is the hypotenuse. And I know it's the hypotenuse because it's across from my 90-degree angle, right? So since I have a case where I have an opposite over a hypotenuse, that's my SO, right? So I know I'm going to use sine. So the sine of 35 degrees equals my opposite side, which is X, over my hypotenuse, which is 20. So that means that X equals 20 times the sine of 35 degrees. Okay, now is where I need some assistance from my calculator, right? 20 times the sine of 35 degrees. 20 times the sine 35 degrees. Check that I'm in degrees, and I get 11.47. Okay, so who ended up with x equals 11.47? If you can tell me. Hopefully everybody did. Yay. Awesome, Jake. Thanks. Jake did. Not you? Oh, Sophia, what happened? Calculator or setting up the problem? Setting up the problem. Okay, so does that make sense now? All right, cool. All right, so now we got to find y. The thing is that you can, when it comes to y, there is many different ways that you could have ended up solving this. Okay, now we have 2 of the 3 sides of a right triangle. So we could say, we could use the Pythagorean theorem, right? We know that x squared plus y squared equals 20 squared. So that would be one way. We can also use our sine and cosine ratios, which is what I'd like to propose to do because we're in this section, and I'll explain which one I want to use and why I want to use that one to find y. All right, so I want to use 35 degrees, and I want to find y, which is my adjacent side, and I want to use 20 because that's given to me. I can solve this problem and use x lots of different ways. I could use the tangent ratio, I could use the Pythagorean theorem, I could do all kinds of things, right? But I want to stick with what they gave me in my original problem, because if I messed up on something on my sine and say I ended up with this is like 13 or something, and then I use 13 to solve my next problem, then I kind of double compounded my mistake, right? So if you stick with trying to use what's given to you, you can't always do that, but if you stick with trying to use what is given to you, then you're more likely to be successful. Okay, so what I said is I have 35 degrees, I have an adjacent side, which is y, and I have a hypotenuse. So if I have adjacent and hypotenuse, that is cosine, right? That's the ka and the SOHCAHTOA. Okay, so I know that the cosine of 35 degrees equals my adjacent side, which is y, over my hypotenuse, which is 20. Okay, I'm going to multiply both sides by 20 to get y by itself. And I get y equals 20 times the cosine of 35 degrees. Switch to my calculator, and I find that that's 16.38. So this equals 16.38. So now you just want to take a step back and look, is this reasonable? My whole gate is 20 feet long. So if for some reason you came up with y was like 0.2, or y is 100, or y is even, 5,000, all of those shouldn't really seem reasonable to you, right? The gate is 20 feet long, then the horizontal component of it should be less than 20 feet. And the vertical component should also be less than 20 feet. So that's kind of the first thing. If you were really wanting to check this out, we could bust out Pythagoras, right? To check. This is just a check. And we could say, oh, well, this is a right triangle. So x squared plus y squared should equal my hypotenuse squared. right? And this means 11.47 squared plus 16.38 squared should equal 20 squared. So then you can just use your calculator to check, right? You don't have to do all of the heavy lifting. You got some tools to help you out. Excuse me. Let's see. Trying to make Desmos a little, there we go. What are we trying to do? Okay. That's what I wanted to do. So if I do 11.47 squared plus 16.38 squared, I end up with 399.865, and 20 squared is 400. So these are pretty darn close. Now with these problems, you do end up with a lot of like slight rounding errors. So I would have to go out a couple more decimal places on each of my side lengths in order to get it to be exact. But we can say that pretty confident that that's correct, right? Okay, how's everybody feel about that? Good? Awesome. You feel good. Jake feels great. I like it. Okay, we're getting near the end of this chapter. I do want to show you, we'll probably finish up on Monday, but I want to show you a little bit of the last section. I don't know if I just closed it. Okay. So we actually did talk about this. We talked about this in class a little bit a couple weeks ago, but these are actually really powerful. They look complex, but they're actually really, really powerful, and they're not too bad. So all of that SOHCAHTOA that we just learned, this is the same exact thing, but we're going to actually learn that if we can find the ratio between two sides, then we can use something called the inverse tangent or the inverse sine or the inverse cosine to actually find the measure of the angle. So sounds very complicated, but not that complicated. Okay, and I think I even showed you guys an example of this. So I'm actually going to start with an example and then talk about what these values mean. Okay, so back in 7.5 when we first introduced this, if I gave you this triangle, and it's a right triangle, right? And I asked you to find the tangent of angle A. Okay, so we have angle A over here, and I asked you to find the tangent of angle A. So you would say, okay, Mr. Ross, I can do that. The tangent of angle A is it's TOA, right? My opposite over my adjacent. So my opposite side here is 16, and my adjacent side is 20. And if I do the reduction work, the tangent of A, 16 over 20 is the same as 4 over 5 or 0.8. Okay, so if you were doing your work in 7.5, done, you found the ratio of the two sides, you're done, right? I think I even mentioned this when we did it. There's actually, once you have that ratio, that number that compares the two sides, then your calculator can actually tell you what the measure of that angle is. And so we know that the tangent of A equals 0.8. Okay. I also can do this thing called the inverse tangent, which is what we're learning about today. So if I take the inverse tangent, which is written like this, of the tangent of A, Okay, so if I do that to the left side, then I have to do that to the right side. The inverse tangent of 0.8. So it's just like if you multiply both sides of the equations by the same thing, divide, whatever it might be, you have to, if you take the inverse tangent on one side or the inverse sine on one side, you have to do that to the other side. The cool thing is that here, the inverse tangent of the tangent, the inverse cancels out. Not cancels out to 0, but cancels out to 1, just like our inverse of a number cancels to 1. So we're left over with A equals the inverse tangent of 0.8. And you might be looking at me like, Mrs. Ross, that does not really help me. That doesn't look that much prettier. However, your calculator has a button to take the arctangent or inverse tangent of a number. Okay, so that is back to Desmos. Okay, if I pull up my keyboard, so let me pull up the keyboard, let's see. There it is. So if I go into Desmos, it's under my functions. It should be wherever your other trigonometric functions are. This is where your phone, like iPhone calculator, I think fails you. Because the iPhone calculator has the trig functions, and it has these hyperbole functions, but it doesn't have the inverse functions. Wah, wah, wah. But Desmos has it, and a TI calculator will have it. So if you don't have it, you might need that for this section. So inverse tangent of 0.8. And make sure you're on degrees. I'm still on degrees. Okay, that's good. Is 38.7 degrees. So that's pretty awesome that I can just have a triangle that's a right triangle and have two sides. And using those two sides, I can figure out, I could have figured out the hypotenuse, right? I can figure out this angle. I can figure out this angle. I can solve the whole triangle just based off of having a right triangle and two sides that are given. Are you guys excited? I can feel the energy. Yay, inverse tangent, right? Okay, so that's what this box up here says. It says tangent with the little -1 to the x is read as the inverse tangent of x. Okay, and so what this says in a bunch of words, if the tangent of A equals x, then the inverse of tangent A, or the tangent x, equals the measure of angle A. So basically, you can use the tangent ratio to find the measure of the angle. That's what it's pretty powerful, right? Better than soccer. Yeah. Now I really believe you, Jake. Okay. Let's try one more of these and then I'll send you guys on your way. I want you guys to try this. I know it's kind of new, but I think we'll try it. And we'll finish up on Monday. So I'll be sending out the test on Monday. I know you guys were all hoping. Okay. I'm not sure what this is. I was trying to put my screen out here. What is this a picture of? It's like a grain, something with grain. It's pumping something, maybe. A pipe pumping some stuff to the pop. I don't know. Can make up whatever you think that picture is. Okay, so you have a triangle. Oh. Well, this one is not even a good example. How are you going to use your inverse sign to figure this out? This is something else. All right, I'm gonna find a different one. It's not a good example. I mean, it's a good example, but not a good example. Give me 1 second. All right, here we go. We need to make up something, a fun story to go along with this triangle, right? Here we go. Jake, I'm going to totally pick on you. I'm sorry. So Jake is going to be, you know, you get an awesome drawing when you have Jake in it, right? Here's Jake on the soccer field, right? And he is 24 feet away from the goal. Okay. Jake, you're probably going to have to correct me because these numbers are not going to all be right. The height of the goal is 10 feet. I don't know what the real height of the goal post is, but let's just say the height of the goal is 10 feet. Okay. And this is a right angle because we're just measuring from the height of the goal post. If Jake is going to kick the ball and he wants to kick this perfect shot, and again, this is not perfect because usually a ball goes in a curve, not in a straight line, but he's going to kick it in a straight line because he's an amazing soccer player. And he wants the ball to go right below the top of the goal. Like he wants to go right underneath it. So technically, let's say our goal post, right, if you measure to the bottom of the goal post, it's 10 feet. This is not the perfect problem, but we're trying to make it somewhat interesting, right? Tell me what angle Jake has to kick the ball at in order for his ball, what angle would make the ball hit the goalpost right at 10 feet? So then we know that he has to be less than an angle when he's kicking it. Okay, so basically I just want you to solve for this angle here, which is, we're going to call K, which is Jake's kicking angle. So I'm going to give you guys 2 minutes to get started and then I'll do it. Figure out what angle Jake's going to kick the ball at. Okay, poor Jake always gets picked on because he's a soccer player, so he probably knows the exact angle that he needs to kick the ball at, right? All right, so what we want to do is we want to figure out the angle. And we have two sides, so we're going to use either the sine, the cosine, and the tangent. Well, the two sides that I gave you are opposite and adjacent sides. We don't have the hypotenuse. We don't know what the hypotenuse is over here, right? We could figure out what the hypotenuse is, but we don't have to in order to solve this problem. So if you did find the hypotenuse and solved, that's okay, completely fine. But we don't have to because we know there is one ratio, the TOA, that doesn't involve our hypotenuse. So I know that the tangent of angle K, okay, equals the opposite over the adjacent, the TOA. The opposite over the adjacent. So the tangent of K equals 10 divided by 24. And if you want to simplify that a little bit, you could say it's 5 over 12. Okay. So again, back in 7.5, you're done, right? Just have to find the ratio. But we want to find the actual angle that Jake's going to kick the ball at. So in order to do that, what we're going to do is we're going to take the inverse tangent of both sides, and that basically gets the angle by itself. Okay, so inverse tangent of 5/12. So we're left with k equals the inverse tangent of 5/12. And once you get there, you can't really solve that on your own. There's not a long way to do that. So you need to go in your calculator and do 5/12 and find out that the angle is 22.6 degrees. Okay, so Jake, if he's going to hit the top of the goalpost on the penalty shot to win the game, which he does not want to do, he would kick the ball at 22.6 degrees or higher. If he's going to score the winning goal by going over the goalie's head right underneath the goalpost, he's going to probably kick his soccer ball at like 21.5 degrees, right? Slightly less to get right underneath the goalpost and to score the winning goal. And the crowd goes wild. So that's how you use inverse tangent. It's actually, like I said, I think that sine, cosine, tangent, and these inverse sines, cosines, and tangents are super helpful. Like they have a lot of practical uses. And so I think it's really important to kind of ingrain that, make sure you get SOHCAHTOA down. And on Monday, we'll do some more examples with sine, cosine, and tangent. Okay. Anybody have any other questions? You excited to walk around and apply the ratios and inverse cosine, tangent, sine ratios? Yes. All right, Jake, thanks for letting me pick on you with your soccer playing. I hope everybody else has a great, well, Jake and everyone else has a great weekend, and I will see you on Monday. Bye, guys.